Okay, physics 30s, we're looking at the nucleus still, page 125. Let's do another example. Let's try question 6. Convert the following to the desired unit. So 10 mega electron volts over c squared, it's a quark. We're converting it to kilograms. Okay, so we know that the energy is given there, and it's given by mc squared. And so we want the mass here, and the mass is energy over c squared. What is with that E? Okay, the energy here is 10 mega electron volts. So convert it to from mega electron volts to electron volts, and then multiply by 1.6 times 10 to the negative 19 joules for every electron volt, and then put that over c squared. Okay, so we want this in kilograms, right? So we have the following. Let's do that calculation. Okay, so there's the mass. (1.8) E negative 29. I did divide it by 3 times 10 to the 8 squared, right? Okay. Take a look at part B. Looking at the mass of an alpha particle, 2 gigaelectron volts over c squared. So we know the mass of an alpha particle from our data sheet, and so let's calculate the energy of it. Mass energy equivalence. So 6.65 E negative 27 kilograms times 3 E8, square that. All right, I got 5.985 E negative 10 joules. Now we want to convert that back into electron volts, and then eventually into gigaelectron volts. So times 1.6, or 1 eV for every 1.6 E negative 19 joules. And then we want to convert that to gigaelectron volts. So 1 GeV for every 10 to the 9 eV. Now you can see our units are going to cancel off. The joules go out with the joules, eV with eV, and then we're left with our gigaelectron volt unit. Okay. All right, I got 3.74. And this would be GeV. So if that's its energy, then its mass is going to be the energy over c squared, which is 3.74, not 54, GeV over c squared, which they generally show just as a little slash there, right? The 3.74 GeV per c squared. All right, let's take a look at the last one, part C. A pi meson has a mass of 139 megaelectron volts over c squared. Convert this to atomic mass units. Okay, well, let's figure out first of all what its mass is. So mass is E over c squared. So notice every time we want to work with mass, we generally have to go to kilograms, and so therefore we need the unit of joules. Joules is a kilogram meter squared per second squared. And so if we want to work with kilograms, we need to make sure we're converting this energy as it's given there, 139 mega electron volts, so E6 electron volts. Now we're converting it to joules, joules for every electron volt, and then we're dividing it by 3E8 squared. All right, 2.471 E negative 28. Now we wanted this in atomic mass units, and so we know that if we want it in atomic mass units, we have to use our constant. One atomic mass unit, they use a little lowercase u, sometimes it's AMU, over 1.66 e negative 27. That's approximately what an atomic mass unit is in kilograms. All right, I got 0.149 atomic mass units. All right, there's some other problems on there you can try out. I'd be a little bit careful with a question like number 4. They don't really show you how they calculate the mass of the nucleons because really we use this idea of the atomic mass unit, which is pretty much like the mass of a proton or the mass of a neutron. Okay, well, similar to. But really, the mass of a proton is a 1.6726 exponent negative 27, and the mass of a neutron is 1.6749 e negative 27. So using this idea of an atomic mass unit doesn't quite work out that way. So I'd be wary with question number 4, but you might want to try question number 3 and number 7. Okay, thank you.